Welcome to fourth quarter. We are starting a brand new unit on, bye Maya. We're starting a brand new unit on linear applications. So it's going to be a lot of an extension of what we did in second quarter whenever we learned that y equals mx plus b type of stuff. This is just going to be an extension into word problems. So this unit will last probably about 3 weeks, and then we're going to move into something called linear regression, which is again an extension of this. So we're going to get really solid with y equals mx plus b type of stuff. So our first one, it says a certain absent-minded student forgets to charge their cell phone overnight. They left their charger at home. Whoops. This is bad because a student likes to Snapchat selfies to their friends during school, and that's not a good thing to do. They should be focused on their education. They're hoping that their phone's battery will make it through the entire day, even though it's not fully charged to begin with. And they notice that after 60 minutes of school, the battery has 46% remaining. After 75 minutes of school has gone by, the phone is down to 43%. And we're going to assume that the battery goes down at a constant rate. So we're going to start by picking two coordinates from this information. And they kind of write themselves. After 60 minutes, there is 46% remaining. I'm going to write that as a coordinate where it's 60, 46. In general, usually time is going to be the x coordinate. So if you ever have a unit that's in time, then that's probably going to be the x. Not always, but usually. The next one says that after 75 minutes of school, the phone has gone down to 43%. So after 75 minutes, the phone has gone down to 43% battery. So those are two coordinates that we can take from the information in the problem. Now it's important to define your variables. What does this x stand for? And what does this y stand for? Well, the x is the 60 and the 75. That stands for minutes. So minutes of school. We're going to type in minutes in school. And then if we look at the y coordinate, the 46 and the 43, that just represents the percent battery remaining. So I'm going to put the y represents the percent of battery remaining. So very important to understand what x represents and what y represents. Now we get to part C, and this is going to be a big review of what we did in second quarter. This says to calculate the equation of the line that is modeled in this scenario. If you remember to calculate the equation of a line, we have to find a couple things. First is the slope. Let's start by finding the slope, and that's going to be y2 minus y1. So here's your y2 minus y1 over x2, that's your 75, minus x1. So 75 minus 60. And if you subtract these, we have 43 take away 46 is a negative 3. And 75 take away 60 is 15. So we have negative 3 over 15. And we could reduce this if we wanted to. Divide the top and bottom by 3. And we get negative 1/5 as your slope. You could turn it into a decimal if you wanted. I think it's going to be easier to interpret later on if we leave it as a fraction. Let's go on to the next part. And we have to find the y-intercept now. So we're going to use y equals mx plus b. And we can pick either of these 2 points. So I'm just going to pick this one, the 60 and 46. So for the y, I'm going to replace it with 46. M represents the slope. So the slope in this case we found was negative 1/5. If you put negative 3/15, you'll still get the same answer in the end. The x is the x coordinate that's up here. That's going to be the 60. So I put a 60 and then plus b. And remember, we're trying to solve for that b. We don't know what b is. We're going to try and find it. So now we can take 46 equals, we take negative 1 times 60, that's negative 60, divide it by 5, and you get negative 12. So by multiplying these together, we get negative 12. And then to get b by itself, we just have to get rid of the minus 12 by doing the opposite. So we're going to add it, and we get b equals 58. And that is our y-intercept. So step 1, we found the slope. That was up here. Step 2, we found the y-intercept. That was here. And now we have to write the final equation. So your final equation is y equals negative 1/5 x plus 58. And this equation is what we're going to be using for the rest of this problem. So it's really, really, really important that you know how to find this equation, because if you don't have this equation right, the rest of it's going to be wrong. So make sure you understand how to get that equation. Part D. What is the y-intercept? And what does the y-intercept represent in this problem? Well, luckily, we've already done this work. Remember when you're finding the equation, this is your slope, and this is your y-intercept. So I know that my y-intercept was 58. And I'm going to write this as a coordinate. The y-intercept is 0, 58. And now we want to interpret this. And this is the x-coordinate, this is the y-coordinate. Remember when we defined our variables early on? This is where it's going to be helpful. The x in this case, if we go up and look, x stood for the minutes in school, and y represents the % battery remaining. So what this means is, if you've been in school for 0 minutes, the amount of battery remaining is 58%. Another way of saying that is, right when school started, there was 58% battery. So when school started, the phone had 58% battery. So that's what the y-intercept represents. Typically, the y-intercept is like a starting point for you. And now we get to the slope. What is the slope of your equation? And what does the slope represent in this problem? So let's take a look here. We have the slope is negative 1/5. So the slope is negative 1/5. And now I'm going to remind you a little bit again from quarter 2. Remember, the slope is the change in y. So it's the change in y over the change in x. So now let's remember, what did y represent? Well, y represented the battery that was remaining. So the change in y, what this means is the battery is going down by 1 over the change in x. This is for every 5, what did x represent? Minutes. So in this case, every 5 minutes, it's going down by 1%. So every 5 minutes, the battery drops 1%. Now remember, I said you could also use negative 3/15 as your slope. This would just mean that every 15 minutes, it's dropping down by 3%. And you can kind of see that if you do this 3 times, then this happens. So either of those interpretations of it means the exact same thing. I like the reduced version, but if you didn't reduce it, that's fine. Now we're going to calculate the x-intercept of this scenario, and we want to know, what does the x-intercept represent? If you remember, again, back to quarter 2, that quarter 2 was really important. To find an x-intercept, we have to change the y to a 0. So let's start with our equation. Y equals negative 1/5 x plus 58. Anytime you want to find an x-intercept, we can just take this y-coordinate and replace it with 0. So we just substitute a 0 for y. And now we have to solve for x. So let's get rid of the 58. we're going to subtract 58 from both sides. And we get negative 58 equals negative 1 over 5x. Let's get rid of that 5 on the bottom. We can multiply by 5 over here and 5 over here. That goes away. And if we take 5 times negative 58, that's going to give us negative 290 equals negative 1x. And then we have to divide. We'll divide by negative 1. And we get x equals a positive 290. Now it's helpful when you are writing x-intercepts or interpreting anything, write it as a coordinate. The x-intercept was 290, 0. So writing it this way will help interpret it a little easier. So this is the x, this is the y. This 290 represents the number of minutes. Remember, x is minutes. The 0 represents the y coordinate, that's the battery remaining. So after 290 minutes, that battery has gone down to nothing, it's dead. So after 290 minutes, the phone has no battery. Phone dies after 290 minutes. So typically the x-intercept will be like the stopping point. So the y-intercept is like where it begins. The x-intercept typically can be where it ends. All right, part G. The phone gives a warning saying, warning, warning, low battery, when there's only 20% of the battery remaining. How many minutes until this warning pops up on the screen? So again, I'm going to start with just a blank copy of the formula. Y equals negative 1/5 x plus 58. Now we have to take the information that's given in the problem. It says there's a warning when there is 20% battery remaining. That 20% battery, should that go in for x or should it go for y? The percent battery is a y coordinate. Remember, the y stood for the battery remaining. So I'm going to replace the y with 20. And then we're going to solve this, so get rid of the 58. We get a negative 38 equals negative 1/5 x. You're going to multiply both sides by 5. And you get negative 190 equals negative 1x. Divide by your negative 1, and we get x equals 190. And what we've just found out was, after 190 minutes, that phone has 20% left. After 190 minutes, the phone will have 20% remaining. All right, if the school day lasts from 8:30 a.m. to 3 p.m., will the student have enough battery power to make it through the day? And explain your answer choice. Well, let's convert these hours into minutes. From 8:30 to 3 p.m., let's just go from 9. From 9 to 3 is 6 hours. So from 9 to 12 is 3 hours, 12 to 3, another 3 hours. But then we have another 30 minutes to get to the 8:30. So if we have 6 hours, 6 hours times 60 minutes, that's 360 minutes that we need, plus another 30 for that other half hour. That phone needs to last 390 minutes. And if we look up here, we determined that phone only has 290 minutes left. So no, it will not last. And in the next video, I'm going to show you how to graph this scenario.